Okay, so I know a lot of you have seen right triangle trig before, but some of you haven't, or some of you might need a refresher, and this video is for you if you're one of those people. So right triangle trig requires that we have a triangle that's a right triangle, meaning that one of the angles is 90 degrees. If you see a little square in a triangle like that, like this, that means it's a right angle. That's how we signify that it's a right angle. And if it's a right angle, then we know some things about the triangle. So we have three trig functions: sine, cosine, and tangent. And you'll learn more about what these functions are in pre-calc, but for now all you really need to know is that right triangles have these different patterns. So if we have an angle A, the sine of that angle is always going to be equal to the opposite length, this length, over the hypotenuse length, so over this length. So let's say that in this case A was 35 degrees. Sine of 35 would have to be equal to opposite length over the hypotenuse length. So what is the sine of 35? For that you need a calculator. You just go into your calculator. There should be a sine function there. So you type in 35 and then take the sine of that. Sine of 35 is 0.57. So basically this means that if we have an angle of 35 degrees, then the opposite side, and the ratio between the opposite side and the hypotenuse is always going to be 0.57. Similarly, we have cosine A. So if I took the cosine of 35, same way, you're going to plug it into your calculator. Cosine of 35 is 0.82. So the ratio between the adjacent side and the hypotenuse of this triangle would be 0.82. And then our final ratio is between the opposite side and the adjacent side. And again, you're going to plug 35 into your tan function, your calculator, 0.70. So the ratio between the opposite side and the adjacent side is going to be 0.70. So these ratios are only going to hold true if you have a right triangle. Otherwise, you can't do all of these things. But let's try this with an example to make it a little more clear what kinds of problems you would have to do. Okay, so number one, we have a right triangle here, signified by this little box. We know that this angle is 34 degrees, and then we know that this side is 20. So, and we want to find this side x. Okay, so looking at this angle, we have one adjacent side. That's the side right next to the angle. This would be the opposite side because it's across from the angle. So we have the adjacent side, and then we have the hypotenuse. So if we have adjacent and hypotenuse, we're going to want to use cosine, since that's the function that uses both adjacent and hypotenuse. So we'd set that up by saying cosine of 34. Cosine of 34 has to equal the adjacent over the hypotenuse. In this case, our adjacent is x, our hypotenuse is 20. So now we've set up this equation. Cos of 34 equals x over 20. Now we gotta find cosine of 34 in our calculators. So let's see, that would be 0.83 equals x over 20. 0.83 times 20 is 16.6. So x equals 16.6. Our adjacent side equals 16.6. Okay, now we could also go the opposite direction. What if we were given two sides and we wanted to find what the angle is? So here I have an angle, let's call this angle A, and I also have the opposite length side and the hypotenuse. So if I have the opposite side and the hypotenuse, I'm going to want to use sine, because that's the one that uses both of those. So sine of A equals opposite over hypotenuse. Sine of A equals 12 over 34. Okay, so sine of A is going to be, what's 12 divided by 34? 0.35. Okay, now I need to solve for A. And we do this by taking the sine inverse of both sides. It also is called arctan. So you could also, or arc sine, you might see it written as. Okay, so you again use your calculator, use the arcsine button or the sine inverse button. This side, because we're taking the inverse, we're just going to be left out with A. And then we need to find the arcsine of 0.35. Plug that into your calculator. And you should get about 21 degrees. Or 0.21. About 21 degrees. Okay, so these are the two types of problems that you'll have to do related to right triangle trig. Please email me or ask me in person if you have any questions.